Hello all. In this video, we are going to correct the forces worksheet. In exercise 1, a spring balance is suspended vertically with its upper fixed end to a support. Okay, this is a support. This is the free end. This is called the fixed end. Its lower end carries a solid S. The spring balance undergoes compression as shown in figure 1. Okay, so the spring is being compressed by the solid ball. The curve in figure 2 shows the variation of the magnitude of the tension exerted by the spring S as function of compression X of the spring. Compression or elongation, it's called X or delta L. Take gravity equals 10 newtons per kilogram. Refer to the graph and complete below the table below. Tension and elongation. When the tension is 1, you can easily see that the elongation is 1, or the compression. When the tension is 3, the compression is 3. When the tension is 5, the compression is also 5. So this is the completed table. Number 2, Hooke's law is given by the relation T equals Kx, where K is a physical quantity that characterizes the spring. Give the name of K. K is called the stiffness constant, or it's also called the Springs constant, but stiffness is better to write. Stiffness constant. Give without justification. Calculate its value in SI units. So we have from the table that when the tension is 1, the compression is 1. Or when the tension is 3, the compression is 3. So we can only take just one reading. So K equals T over X. This is from Hooke's law. T equals K times X. Hooke's law. We should write it. K equals T over X. So substituting 1 over 1 equals 1 newtons per centimeter. We are asked to calculate it in SI units. So to convert from Newton per centimeter to Newton per meter, we multiply by 100. We can also solve this again by converting the compression into meters from here. It will be 1 over 0.01, which is 100 newtons per meters as this answer. Number 4, S is submitted to 2 forces. T is one of them, the tension. Name the other force. The other force is weight. As you know, we have 2 forces acting on the solid, which are the weight and the tension. Okay, S is in equilibrium. The maximum compression of the spring is X equals 6 centimeters. Write the condition of equilibrium. The condition of equilibrium includes all the forces acting on the block, which are the tension and the weight. So tension plus weight vector equal a 0 vector condition of equilibrium. We can begin with sigma F equals to 0 before this, but it's okay to start with T plus W. So the tension equal minus weight vector. So and the magnitude relation is tension equals weight. Give graphically the magnitude of the corresponding tension. When the compression is 6, graphically the tension is also 6 newtons. Part C, deduce the maximum magnitude of the weight. So now we have the tension. The weight is equal to tension as the magnitude relation. So weight is also equal to 6 newtons. It's all substitution. Calculate the maximum value of the mass. So now we have the weight. To calculate the mass, we say that mass equals weight over gravity, or weight equal mass times gravity. We calculate now the mass as 0.6 kilograms. Number 6, finally, the greengrocer cannot use this spring balance to measure 1 kilograms of potato bag. Justify. So what does 1 kilograms of potato bag make a compression for the spring? So 1 grams of potato bag makes 10 newtons as weight. So weight equal mass times gravity. It's 10 newtons, which is greater than the maximum allowed tension. In number 5, we deduced that the maximum compression is 6. The maximum allowed tension is 6 newtons. So this weight, 10 newtons, is greater than 6 newtons, so it is greater than the maximum allowed tension. In this case, the spring loses its elasticity. بينتزع الرسول، بيصير هيك مثل كأنه خد، بيمزع. Now, in exercise 2, it's a simple question. S is a solid body of mass 300 grams. Of course, we should convert it into kilograms. The gravity is 10, stiffness 2 newtons per centimeters. This is the description of this figure. Name the other force exerted on us other than weight, which is tension. Specify the vector relation. The vector relation is T vector plus W vector equals 0 vector. Condition of equilibrium, you can stop here since this is the vector relation. If you are asked as the relation of the relation between the two forces, you can reach as here, T plus W. Okay, but the vector relation you can stop in this step. Number 3, calculate the value of each one of the two forces. To calculate the weight, we have the mass, 300 grams. We convert it into kilograms, which is 0.3 kilograms divided by 1000, which is 0.3 times the gravity 10, which is 3 newtons. To calculate the tension, we cannot say T equal K times delta L, since we do not have the elongation delta L. So we use the condition of equilibrium T equal W, which is 3 newtons. We calculated W equal 3 newtons. Now we deduce the elongation. We deduce the elongation from the tension. So we apply Hooke's law, T equal K times delta L. So delta L equal T over K. We calculated T as 3 newtons and K as 2 newtons per centimeters. So 2 newtons per centimeters, newtons with newtons, they're cancelled. The unit of delta L is centimeters.